Hey guys, sorry I couldn't be here with you today. I wanted to take this opportunity to go over problem of the day with you. So I noticed that some of you guys are getting confused about the two rules that you have here. Here you have them both in one. You have the power rule here, and then you have the product rule once you're done with that. So we're gonna attack it from left to right. So we're gonna do the product rule first. Okay, and the product rule says that we have to multiply the powers. So 3 times a -2, that's a -6. And then I'm going to rewrite my -6 and I'm going to add it to the +4 because that's what the product rule says. So 5 to the -6 plus 5 to the power of 4 is equal to 5 to the -2 or 1/5 squared. So there's a couple of areas where students make mistakes. Sometimes they make the mistake here of adding instead of multiplying. So be sure to multiply. Sometimes they make a mistake here. Be sure to add. Sometimes they make a mistake here by not adding the integers correctly. And sometimes they make a mistake here by not converting between the two. So those are the 4 places that you have to watch out, and you guys have your formative on this tomorrow, so you can use this to help you study because there are going to be problems like this. So what's coming up today, you guys are going to learn about positive scientific notation. You're going to kind of build off what you learned yesterday about powers of 10. So you're going to do your problem of the day, which we just did, mini lesson, and then you'll have plenty of time to work, and then you'll close. So just keep in mind that you guys have your formative on Thursday. It's going to cover the exponent rules. You guys can refer to your exit card. You can refer to your independent work. Some of you are going to get that back today. And the independent work that you got yesterday, that's due on Friday. I have keys available for the independent work. They're on my desk. They're right there. But I didn't fill them out completely because it's just a lot of tables this week. It would have been easy to copy. So there's just kind of clues there. All right. So what is the distance? We're going to be a little bit curious today. We're going to kind of get into a scientific mindset. What is the distance from Earth to other planets in space? Is that going to be a big or a small distance? Okay, I think we can agree that the distance between the planets in space, that's a big distance. So we're going to use this idea of scientific notation, which is a shorthand that mathematicians and scientists develop to represent either really big or really small numbers. It has a standard form, okay? When I say really big, I mean like really big off the calculator, like huge numbers. So let's look at the distance from the Earth to the Sun. So that distance is 92,960,000 miles. It's a really big number. So what scientists said is they said, well, I want to write it as a power of 10, and that's going to help me save time. So here's what they did. The first thing they did is they said, well, I'm going to include all the digits that I have here. So here you can see I have a 9, 2, 9, and 6, okay? And I got those digits from these 4 digits right here, 9, 2, 9, and 6. The other thing that the scientist said was, I'm going to put a decimal point after my first number. And I don't know, there's not that much reasoning for that. That's just how scientific notation is always written. You always have a number in the ones place, you have a decimal point, and then you can have like 2 or 3, sometimes more, but usually 2 or 3 numbers after the decimal place here. And then what they decided to do was to connect it to a power of 10. Because remember that when I have a power of 10, all a power of 10 means is that, or when I multiply by a power of 10, my decimal place is going to move to the right. And if you think about the chart that we did yesterday, that makes a lot of sense. So what do I need to multiply 9.296 by in order to get up to the millions place? Well, I can count my place value. So my decimal point is here now. So I can count 1, 2, 3, 4, 5, 6, 7 places over to the right. 9.296 times 10 to the 7th power. So both of these numbers are the same. I've just written this in a shorthand and scientific notation, so I don't have to get confused by all of these numbers of zeros. So here's another example, and I can see that this is another really big number. It's huge, in fact. It's even bigger than the one before. I actually didn't know that the Earth was further from Mars than it was from the sun. I kind of figured it would be further to the sun, but apparently that's not true. I learned that today. So same thing. I'm going to set it up in my standard form in scientific notation. And the first thing I'm going to do is I'm going to write my digits. 1, 4, 1, and 6. And I'm going to put my decimal point right here because, again, in order for a number to be in scientific notation, I have a digit in the ones place and then I have whatever numbers come after that. Now I know I'm going to multiply it by a power of 10 because that's what helps the number to get really big. And again, I know that when I multiply by a power of 10, the numbers are getting bigger, the decimal place is moving to the right. So I can count how many decimal places do I have? 1, 2, 3, 4, 5, 6, 7, 8. So that means that if I multiply 1.416 times 10 to the 8th power, I'll end up with this big number that's in the millions. These two are equal, and I can write them, they're the same, I can write them either way, but this is the way to write it in scientific notation in the shorthand. All right, so this looks blank on your page, but I also found the distance from Earth to Venus, and I wrote it in scientific notation, and we are going to expand it into a big number. We know it's a big number. The distance from Earth to Venus is definitely going to be a far distance. So to work backwards, I'm going to start with my digits again. So my digits were 6, 7, 2, 4. 6, 7, 2, and 4. And I can see my power here is 7, okay? So that means I have to move my decimal point 7 times. Now here, my decimal point is right here. So here we go. 1, 2, 3, 4, 5, 6, 7. So that's where my decimal point is gonna end up. What am I gonna do with all these blank spaces? I'm gonna put zeros here. The zeros show the places. They show, they're just placeholders. They're showing me how big the number is. So I'm gonna do a comma here, a comma here. I'm actually gonna rewrite it so I can see it more clearly. No, I didn't get my commas right, actually. So it's actually this. So the distance from Earth to Venus is 67,240,000 miles, or 6.724 times 10 to the 7th power. Okay, so I hope that was helpful, and if you want to watch the video again, you can. Otherwise, you can get started on the self-check, which has you practicing these ideas, again, using these really large distances. Earth to the moon, Earth to Jupiter, Maryland to Australia, DC to Pyeongchang, that's where the Olympics are right now. So you're getting the idea of how to work back and forth between the big numbers and the scientific notation. Okay guys, have a great day and I'll see you tomorrow.